You know, it really feels like every time you turn on the news, there's another headline about a record-breaking flood or a catastrophic wildfire or some unprecedented heat wave. It's easy to get numb to it, right? But what if these aren't just a string of bad luck? What if they're all connected? Today, we're going to go way beyond the headlines. We're going to break down the actual science that links these disasters into one big, cohesive story about our changing planet. Just look at this. This isn't some old boat graveyard. This is, was, Lake Pátzcuaro in Mexico, absolutely ravaged by a multi-year drought. This is what extreme weather looks like on the ground. It's a powerful, frankly heartbreaking reminder of the real impact these events have on people's lives and on entire ecosystems. So, to really get what's going on, we need to zoom out. We have to look at the big picture, the global scale. Because when you do that, the trend, it becomes impossible to ignore.
And here's what that trend looks like as a number. The frequency of recorded climate-related disasters, we're talking storms, floods, droughts, has shot up 5-fold since the 1970s. I mean, think about that for a second. In the 70s, we saw about 700 of these major events. In recent decades, over 3,000. That's not a small bump. That is a massive, fundamental shift in how our world's weather works.
Okay, so a 5-fold increase. That immediately begs the question, what on earth is driving this? To figure that out, we've got to look under the hood at our planet's climate system. Let's think of it as a kind of climate engine.
So, it all starts with a basic law of physics. Now, it's got a super complicated name, the Clausius-Clapeyron equation, but the idea behind it is actually incredibly simple. All it says is this: warmer air can hold more water vapor. Or, to put it another way, a warmer atmosphere is a thirstier atmosphere. And we know exactly how much thirstier. For every single degree Celsius of warming, the atmosphere can hold about 7% more moisture. All that extra water vapor up there, it's like loading a spring. It's just potential energy, waiting for the right moment to be unleashed as way more intense, concentrated rain.
Right, so part 2 of our climate engine is the ocean. The best way to think about this is that warm ocean water is basically high-octane fuel for storms. Seriously, when you have abnormally high sea surface temperatures, you're just pouring raw energy into the system. Energy that can rapidly blow up a tropical storm into a massive, destructive hurricane.
And a third piece of this puzzle is the jet stream, that big river of air flowing high above us. It used to be pretty stable, flowing fast and straight, almost like a taut rope. And that's because there was a huge temperature difference between the icy Arctic and the warm tropics. But here's the thing, the Arctic is warming way faster than anywhere else. That temperature difference is shrinking, and so the jet stream is losing its tension. It's becoming slower, weaker, and wavier, more like a lazy, meandering river. And it's those big, slow loops that cause weather systems to just get stuck, sitting over one area for days and days on end. Okay, so we've got the 3 main parts of our overheating engine: a thirstier atmosphere, supercharged oceans, and a wobbly jet stream. Now let's connect those dots directly to the hazards we're all seeing.
You can see it's a really clear cause and effect chain. A thirstier atmosphere, that directly leads to more intense downpours and, of course, more flooding. Superfueled oceans, you guessed it, they spawn stronger, more dangerous hurricanes. And that wobbly, lazy jet stream, that's the culprit behind those brutal, seemingly endless heat waves and those persistent, punishing droughts.
And we are seeing these consequences play out everywhere. We now know that big droughts aren't just more common, they're hotter and drier, creating the perfect tinderbox for those catastrophic wildfires. And when a storm gets stalled by that wavy jet stream, like Hurricane Harvey did over Texas, the results are just mind-boggling. That one storm dropped an estimated 127 billion gallons of water. It's almost impossible to even imagine that much rain.
But all of this brings us to the really crucial question. It's the one that scientists, until pretty recently, have really struggled to answer with any certainty. Can we actually blame climate change for any single specific event?
You know the question. We've all asked it, or at least heard it after a disaster. Was this specific hurricane or this particular heat wave caused by climate change? Even a decade ago, the answer from scientists was usually, we can't really say for sure. But that's not the case anymore. A whole new field of science called extreme event attribution is now giving us some incredibly clear answers.
So scientists have 2 main ways of tackling this. The first is a risk-based approach. This is all about probability. They use powerful computer models to compare our world today with a virtual world without any human-caused climate change, just to see how much the odds have shifted. The other method is the storyline approach. This is more like forensic analysis. Think of it like CSI for weather. They basically accept that the event happened, and then they look for the fingerprints of climate change. They ask, okay, given the weather patterns, how much more intense or damaging was this storm because of all that extra heat and moisture in the system?
And the group leading this charge is an amazing international team of experts called the World Weather Attribution Initiative. You can think of them as rapid response climate detectives. They jump on these extreme events almost as they're happening and use these really rigorous methods to give us scientifically solid answers in a matter of weeks, not years. It's a real game changer.
And their findings? They are just stunning. They found that the deadly 2022 heat wave in India and Pakistan was made 30 times more likely because of climate change. The devastating floods in West Africa that same year, a staggering 80 times more likely. But what really shows you how objective their science is this last one. They looked at the famine-inducing drought in Madagascar in 2021 and concluded that it was actually driven by factors other than climate change. They just follow the data, no matter where it leads.
So we have the science, and we can now connect these dots with real confidence. Which brings us to the big one. What does all this actually mean for us, for our lives, for our economy, and for our future?
Honestly, the best way to wrap your head around it is with this loaded dice analogy. Climate change hasn't invented new types of weather, but what it has done is load the dice. It's making a roll for extreme heat or extreme rain far, far more likely than it used to be. We've basically stacked the deck against ourselves in favor of more severe and more frequent disasters.
And that new reality comes with a staggering price tag. For 6 years in a row now, insured losses from natural catastrophes have topped $100 billion. And you got to remember, that's not even the total economic damage. That's just the stuff that was insured.
You know, this isn't some abstract problem for the future. It is forcing major global industries to completely rethink how they operate. As one big risk management firm put it, the old models they used to predict risk just don't work anymore. Insurers are now caught in this upward spiral of risks and costs, a spiral that, by the way, ultimately affects all of us through our insurance premiums and policies.
So this leaves us with one final and I think really critical question. It's just human nature to prepare based on the last disaster we experienced. But the science is telling us loud and clear that the goalposts are constantly moving. The records we see today will almost certainly be broken tomorrow. So the real question for all of us is, are we preparing for the world we used to have, or are we using our imagination to actually prepare for the one that's coming? That's the challenge this science puts right in front of us.